Okay, so this is quality management, and this is chapter number 17 of the book. There's a there's a role of quality management in every process in business. So if you see the production, if you see the service operations, if you see the call quality, if you see the defects in any products, or if you see any process in management, there is a role of quality, and how to keep the quality intact, that is the biggest challenge. And therefore the statistics play vital role in quality management. And some of them, we are going to learn some of the techniques, how can we see the quality and how we can check the quality. Actually these are all theoretical part, but very important for every one of us to understand and learn. So what is quality? Quality may be measured, so I'm not going to give the lecture, because you can go through first few pages and that will give you the uh, you know understanding how quality evolves, who are the people, those who contributed in quality management. So basically the purpose of quality is to reduce the variation in production or any process. That is the main aim of quality management. Common cause of, so basically this is all theory. I think you can go. The role of statistics is very important because it measures the variation, and we have been studying in all modules, or those who have done 503. So variation, that is important. This is another important thing. When the quality control or quality management is started, who are the pioneer? So I would like to give a little brief about early 90s. This improvement, so quality look the form of improved inspection and improvement in the method of mass production. Then 1920 CORT started, process control charts. 1950 to 60, Deming and Juran. These are the great people, and they are then Taguchi and Ishikawa. They are Japanese statisticians, and they contributed into this. 17, there are many things, and then 80s, Deming, Juran, and all they came, and the Kaizen philosophy, Six Sigma, you might know about, because now ISO standards in Europe. So you might be hearing a lot of these jargons in business process management and quality control. So there is a Deming Award also. There is ISO certification. There is a many quality certifications. If you understand the all these concepts that we are learning in 503 and 520, and probably you will get the some black belt, yellow black belt not, but at least you can get a green or yellow belt in Six Sigma. Six Sigma is another certification that gives you the skills and validation of your skills in quality management. And therefore there is a Six Sigma certification, various level. I have one of them. So uh, these are the other points that you can go through. Basically you need to read. I'm not giving the lecture, I'm just going to uh, start about the main thing from these slides. So basically, if you can see, there are few descriptive tools: Pareto diagram, scatter plots, box plots, fishbone diagram, check sheet. These are the descriptive tools in order to control the quality. We have analytical tools, that is control charts, and we are going to learn the control charts today. Accepting sampling, experimental design, Taguchi robust designs. These, we learn sampling design and sampling level and sampling in previous course. But our main focus today is control charts that we have on in Minitab. But I'm going to explain these descriptive tools too. So these are some of the examples that you can go through. So what is the Pareto chart? Pareto chart is 80-20 rules. That means 80%, you know, uh, so 80% performance or 80% problem can be solved if you fixed, I think. Uh, okay, so today many students might not have. Okay, okay. Hmm. So do you want me to send the link? So what do you want me to do? Uh, if you have any question, you can talk to me, or if you want, we can have this session on Saturday. It's all up to you, because I want maximum students to get the benefit out of this. Yeah, even I got the email about the the IT outage and server problem and other things. Everyone, it's all up to you, so I don't mind.
I think it's good that you are recording it, so that means that the people that is not present today, they can just go back to it and just see the explanation and then ask you questions if they have questions. I just think that.
Okay, yeah, I mean, so even if you want Saturday, I can do at the same time, 5:30 p.m. That is our official time. So you so so okay, let me go briefly, and then if you don't understand or other people have, I can also go over on Saturday, or I can again explains. Okay, so I think now, yeah, we have 6 out of 11. So yeah, so yeah, it is today really, server issue is there. Okay, let me go ahead. What is the Pareto chart? Pareto chart is it actually Pareto chart is also known as 80-20 rules. That means 80% of problems can be solved if you fix 20% of issues, or 80% performance can be improved if you fixed 20% of reasons. And basically, Pareto chart can be made in Minitab. Basically, it is two combination of two charts. One is column, this column chart, and ogive. Ogive is the cumulative line. So they plot together, and then this is made. A scatter plot is plotting the two variables on one sheet, and then you can understand from the dots that which dot is going out of the control, which is out of the limit, which is having consistency. Box plot is another thing that you can see, you know if it is normally distributed, how it is, which side it is having skewed, skewness is right skewed, left skewed. So these basic uh, plot or graphs can give you some idea about this. So let me go with some of them. Here I don't have data for parrot chart. Here, if you can see under statistics, here you have two options. One is control charts that we are going to learn later. Quality tools. quality tools, Pareto chart. And when you have, uh, when you have defects or attribute data here, frequencies is here and here, So if you have this and data that I think I don't have right now, you can plot the uh, Pareto chart. Now let's go under graph. Here we have the scatter chart, and I'm just going to plot by randomly for midnight and at 600. So okay, and midnight and at 600. So basically this is a scatter plot that all the charts can be, or all the graphs and charts can be plot under this. You have also an option under this assistant, and under assistant you have the control charts, you have before after control charts, you have before after capability analysis. So here you have also graphical analysis. Here, this is very well explained. What is your objective? Graph the distribution of data, graph variables over time. So basically this is time series, I chart, IMR chart, X bar R chart and all. And here help me choose a scatter plot, and this. And the another thing, cause and effect diagram. Yeah, box plot. So you go under graph. Here you can see the box plot here, right here. I'm just going to pick some random. You can see this is box plot, and you can put middle. When you go under edit, you can find the levels, Q1 median, Q3, and interquarter range and everything. Now, other important thing is fishbone diagram, which is also called by three names. There are three names of the same thing, which is called Ishikawa diagram. We call cause and effect diagram, and so this is fishbone chart. We call three things. Fishbone, we also call it cause and effect, and Ishikawa. So these are the three names of the same thing. And these are the normal categories that so basically excessive length of stay is due to technology, measurement, management, material, method, and people. How do we plot? So Minitab helps us to do this job here in our. So let me do this on Minitab. So let's say think about the COVID situation. COVID situation is increasing. Number of COVID patients are increasing outwards because of there are, let's say, many reasons. Number one, I would say man. So I can say no distance, no self control. I would say self discipline. Let me. Okay. Then machine. What is the reason? How much time it takes in order to get the test results late, or we don't have the machine. Quick results machine, or better word to frame, quick uh, uh, test results, no lack of quick test results. And technology, you can list down all the reasons in this, all the causes basically under each column. So uh, so basically technology is tracking COVID patients. Now, three other reasons are material, and I would say no drug, no vaccine, uh, and then method and pupil. Pupil I already shared. Measurement, I think measurement would be in management. Governments, government policies, basically, I would say policies, lockdown, and material, methods and material. Method, I think method will have policies, I would say. uh, Method, uh, just say some word, I'm just putting xyz. So 1 2 3 4 5 6, I think I, or here I would say pupil, and we can list down here, and under here, if I go under statistics, here we have quality tools, and where is the cause and effect diagram. So personal in column, where I have pupil is in column. Okay, this is pupil. Then machine is here, material is here, method is here, where is measurement? I did not put. Okay, let it be. Uh, Environment. So basically, I think technology. Let me put. I'm just doing it. Technology, material, machine. Okay, I have done. What is the effect? COVID outburst. Title, I can give any title. Cause and effect of COVID 19. Okay. So here you can see this is my cause and effect. I can copy here and I can paste anywhere like you do in your assignment. So this is Fishbone diagram, or cause and effect, or Ishikawa. Uh, Check sheet is the one which you have, I don't think I need to explain. That is just simple check sheet. You keep all the items, you work breakdown structure of your entire process, and you see, okay, like, we go to the car inspection or car services, they have the checklist, whether they have performed all those things. That is check sheet. So again, few things. And now total quality management means quality in everything. That is another subject itself in operations management, TQM. TQM is not only in processes, in man, machine, in all the aspect, that all business activities should be oriented toward meeting and exceeding customer needs, empowering employees, eliminating wastage or rework, and ensuring a long run viability of the enterprise through continuous quality improvement. So quality is not just one time effort. It's a continuous process, and that is what is TQM. It is not only in the process, it is in employees, customer, so that is called TQM. Let's say I give you a very simple example of total quality management in education. What do you think? What is the TQM in education? Let's say total quality management in Eastern Washington University. That means there should be a process to train, educate, improve, train employees, train faculty with all the new technologies, train, give the orientation to the students and counselors or your academic advisors and whoever is there in their businesses and their roles. Also, the processes has to be improved. So that means each and everything, the IT has to be upgraded, IT has to keep continuously upgrading. So that is what is total quality management. Business process re-engineering means altogether new way of engineering the processes. So let's say this process seek radical redesign of the process to achieve breakthrough improvement in performance measures. So basically, re-engineering means all the new way to radically improve the process. So for example, like the, the entire education has been redesigned in this COVID situation. All the business education businesses have been redesigned. Not, I am not talking about here in USA, because we have classes, online classes already, and we have the same system here. However, in India, nobody used to go online classes. They, even small kids and small education institute, elementary schools and everything, and we don't have that facility. So whatever technology they have, they are just using maximum use of that. Let's say giving the lectures, what they are doing, what is the freeware available, because in India they can't pay huge money for Zoom or other companies. They are using free Zoom services to meet students for 40 minutes. And what is the maximum time is allowed? I think 100, maximum students are 100 at a time. So 100, 40 minutes, then another section of 140 minutes, another meeting. And they are, most of them are using their camera and mobile phone and their video recording to upload on YouTube. And then, so this is the way. That is called business process redesign and reengineering. So here, detecting abnormal patterns. So these are the 4 rules which are given in the book. Single point outside 3 sigma, 2 or 3 successive point outside. So basically these are the rules we will follow later. Quality. So this is, basically 6 sigma is based on this TMAC. So those who are really interested to pursue quality, because if you have quality 6 sigma black belt, you can write your own check. That means 6 sigma steps is based on define, measure, analyze, improve, and control. And these are the 7 steps in order to improve continuously, quality continuously improvement. So even this is very important you to remember. So what is 6 sigma? So what is a, I think somebody please mute your microphone. Okay, so now we are going on control chart. What is a control chart? A control chart is visual display that plots the value of sample statistics over time through repeated observations. Random sampling is often needed to reduce cost or time. So basically, if any production is happening, let's say in assembly line, Assembly line, somebody is manufacturing, let's say, a very small product. They want to see their production process is in control, or the product is coming as per the dimension, at per the specification. How they can check whether there is a variation in the production. Let's say there's a weight of any product is 10 gram or 10 gram or 10 ounce or whatever unit you want to prefer. Is that in control? So they have randomly selected couple of items, and now they would like to check the process in control, and they would like to see it. So for that purpose, their control charts are there. Two types of data: numerical data. Control chart display the measure of central tendency, you know and the variable control chart. So without, the subgroup size should be, so variable control chart of numerical data may be quite small or even a single item. So let me go over the control chart. Three common control charts are there. One is X chart, R chart, and P chart, and very easily to understand which chart has to be applied. So X chart is mean chart, X is mean chart, R chart is range chart, P is proportion chart. So these are mean, range, and proportion. So now let me go over the Minitab. So I have the data right here. So this is, for example, these are the 4 samples: midnight, at 6 o'clock, at 12 o'clock, at 18 o'clock. So, something 20 samples are there at 4 shift, midnight to 8, 6, in each 6 hours time. And this is the mean of all 4 shift sample. So let me go under stat. We can go under this also control chart. Now we have to see data type, continuous or attributed. Continuous, you can use IMR chart, X bar chart, X bar R chart. So data collected in subgroups. Yes, we have subgroups: midnight, 6 o'clock. Subgroup size 8 or less, or subgroup size uh, uh, 8 or more. Size greater than, sorry, this is up to 8 and this is more than 8. Here, so this is continuous data. If you have categorical data, or if you have, proportion data, of you have number of defects per unit. So defects per unit, then you can use U chart. And if you have defect item, proportion part, you can use P chart. So uh, this is properly explained in this hierarchy. Now let me go with, and there's another option: statistics, basic control chart. Under control chart, here you can see, here you have XR chart, X bar S chart, IMR chart, and these are all. Here you have attributes charts, P chart and U chart. So P and C chart. So these are the different other charts. However, most of the assignment that I gave you are based on X, X or XR. So let me go with one by one. So X bar chart. So here you can see observation for a subgroup are in one row of column. Observations, all observation for chart in one column. So we don't have in one column. here we have, so I'm just going to, because I'm not going to keep mean, because that is just average of all four. Select X bar options. Here you need to select, perform test, special cost, perform test for space, perform no test. So basically I'm not going to do anything, just let it be. Data options, here you have multiple groups. Levels, you can put also levels, we don't want to put scale. And here we have, now just put, here you can see this is X bar chart. What does it explain? Here you can see the test one. 1 point more than 3 standard deviation from center line, test failed at 0.6. What it is explaining? So basically this is mean, which is mean X bar, as you know. What is the upper limit? What is the lower limit? Upper limit and lower limit are the 6 standard deviation. If you remember, mean plus 3 standard deviation, mean minus 3 standard deviation. So this is mean minus 3 standard deviation is this, mean plus 3 standard deviation is this. So it is clearly, that means 1 point is going out of the control. So this process is not in control because because 1 point, because test fell at point number 6 is going out of the 6 sigma limit, or 3 sigma, upper 3 sigma limit. Therefore, we can't say this process is in control. Very simple. This is what we want to conclude. So similarly, let me go with uh, stat uh, control charts. Here I am going to do this XR chart for same data. Okay, look into that. 1 point more than exactly the same. Here you can see this is sample, this is the range. Range is in control. You can see, I'm just going to use my pen. Here you can see in this graph, in this chart, this is the range. Range is in within control. So this is upper limit, this is lower limit, and you can see this is even less than 2 sigma. I believe this is less than 2 sigma. Within 2 sigma of the range. So range is in very, or this is very much in control. It's proper. However, the process mean is not in control, because this point number 6 is going, let's say the thing which you have stat uh, control chart, and this I go for X bar and S chart. What is the meaning of S? S mean that we studied standard deviation. So I'm going to, so X bar and S chart. Look into that. So variance, or the standard deviation and variance, that this isn't very much in control. This is well controlled. However, the mean process mean is not in control because of exactly the same reason. So this is X bar. This is basically we can understand. Now go under this as start, and here, sorry, statistics control charts. So here X bar R range, and as you got these three meanings of three charts, now you got these two charts also. So this is basically used, let me used individual. What is the meaning of this? Individual moving. So this is, let me make it bigger, view. So this is subgroup means which we have just, this is this, MR is this, you can see, and here in all three cases, here you can see between, within, IMR. So this is third group, third chart that is important. However, assistance and control charts. Here data collected in subgroups, if you don't have this data collected in, but you know, here we have, I just run, then you use IMR chart. If you have up to 8 or subgroup size 8 or less, so how many subgroups we have in this case? One subgroup, two group, three group, four group. How many? Four groups we have. And subgroup size greater than 8, then we are going to use X bar S chart. So similarly, we can go for P chart. However, we don't have the data here based on P chart. Number of defect item column, how many, and subgroup. So here also we can put the data based on that, or we can go here statistics. Again, control charts. So here, so here we have IMR chart. Variables, I'm just going to use the individual moving range chart. So this is individual value and this is moving range chart. Here you can see moving range. You can see these points 1, 2, 3, 4. These are the moving range is coming towards lower control limit. This is lower control limit, which is 0, and this is upper control limit, which is 7.3. So this is 3, 4 points. 4 points are touching the lower control limit. Now let me go with some theoretical aspect. Three common control charts, P charts. Sample size. So basically this is what is the upper control limit and lower control limit. So that line that you are able to see, which is mu plus 3 sigma, 3 sigma square root by n, mu minus 3 sigma square root by n. So this is upper and lower limit, upper control limit and lower control limit, which is 3 standard error from the central line. The empirical rule says, as you remember, 99.73% of sample means will fall within 3 sigma limit, that you know the limit of 6 sigma. So unknown mu and unknown sigma, so basically X bar plus, so if you know known mu and sigma, this is the control limit, but you don't do it because automatically you get in Minitab. If unknown, this is the control limit. So basically, what is the difference? Here you have population mean. This is population mean. This is population standard deviation, and this is sample size. Remember, this is population parameters, and here this is statistics. So this is sample mean, sample standard deviation, and sample size. So this is control limits, because in question you will be asked, so you have to do this. If population is given, you need to use this. If formula is same, but you know the notations, parameter and the statistics are changed. So exactly the same thing. Detecting abnormal patterns, and there are 4 rules for that, how you can detect. Rule number 1, beyond 3 sigma. So this is what we have just seen, that in our case, this is, I think we did, this is beyond 3 sigma, so which is this. So this is rule number 1 that is applicable in our this chart. Only this rule is applicable, which is only one item out of 3 sigma. So this is beyond 3 sigma. This is first case. This is the second case. Second case says, so for example, these are the 3 lower control limit, upper control limit. These are 3 sigma, 3 plus or 3 minus sigma limit. However, if I say this is 2 sigma and this is 2 sigma, 2 sigma, 2 sigma. So this is 2 sigma, 2 sigma. This is line of 3 sigma, 3 sigma, and this is 1 sigma, or you can say simply sigma. Length of the time, so 2 of 3, 2 of 3 beyond 2 sigma length of the time. So basically this is rule number 2. So basically these 2 are beyond 2 sigma. This is rule number 2. Now look into the third rule. So we have 4 rule. What this says, 4 of 5 beyond 1 sigma. So this is the 1 sigma line. This is the 1 sigma line. So 4 out of 5, 4 of 5 beyond 1 sigma. Continuous, that is also continuous. So let me tell you, this is also, and then you can say there are many more which is beyond these lines, beyond 1 sigma. Successive, basically I'm going to go over the wording, and 9 successive same side. So basically, so this is mean 1 2 3 4 5. These are the 9, I believe. 1 2 3 4 5 6 7 8 9. Yes, 9 successive same side. Here 4 of 5 beyond 1 sigma, and that is also successive. So why? Because these observations are coming. What is the interpretation that you can get from here? Any process at these points, these 15 to 20 points, in between 15 to 20 points, why all observations or all the process moving towards one side? Probably there is some issue in machine or some issue in that, coming everything. If it is coming sinusoidal, we can understand, or we can understand 1 2 or something. But successive 4 is coming, successive 9 is coming, or other things are coming. That means we have to inspect, we have to check our process, we have to look into that in order to correct that. So this is Here is the, let me, so these are the 4 rules that we have to. Number 1, single point outside 3 sigma. Number 2, 2 of 3 successive points outside 2 sigma on the same side of central line. Number 3, 4 of the 5 successive points outside 1 sigma on the same side of the central line. And rule number 4, 9 successive points on the same side of the. So basically you have to test in your, whether you have rule 1 applied, or rule 1 appears in your pattern, rule 2 appears, so which rule is applicable in your chart. So this is, you have to observe this part also. So this is 4 rules. Yeah, these are clearly written, I think, here. 9 successive point on the same side. Control charts for mean. So this is exactly the, what is the 6 sigma? If you remember the basic thing, 68.2% plus minus 1 standard deviation, 95.44 plus minus 2 standard deviation, 99.73 plus minus 3 standard deviation. So this is these are the basic empirical rules that we always, and we also use in different statistical calculation. So control limits for range, this is the so we just check the control limits for mean. Now control limits for range, upper control limit, lower control. So this is D4, D3, and R means range. So, or you can do this in this way. So actually we get all this number in our other control charts, which is P chart, based on the proportion, number of non-conforming items upon sample size. So let's say a very simple thing. I showed you the Indian student data, research university and not research university. And if let's say 500, we took a 500 data, sample size is 500, and let's say 100 are research university. So this proportion is 20%. 100 divided, which is 20%. So proportion. So based on that, if you have this data, you can do the P chart. And this is control limit for P chart, proportion. I mean, this is proportion, minus 3, proportion, 1 minus proportion. So this is basically based on the exactly the same formula. However, instead of mean, instead of standard deviation, these are the formulas for proportion. Other control charts. Now pattern in control charts. Abnormal patterns, cyclic, oscillation, instability, level shift, trend, and mixture. So basically, I'm not going into all the data, but you can see from the pattern which kind of thing are there. The last thing related to this module is about process capability. Customer requirement. So basically look into the process capability. These are the 2 index we have here. One is CP index and one is CPK index. These are the 2 index that we have in this. What is the interpretation? We don't have assignment into this, but I would like to let you know what is the importance of this. So this index is a ratio upper SL minus lower SL divided by 6 sigma. SL mean a standard deviation. And 6 sigma is the total range. So basically lower limit, lower standard deviation, upper standard deviation divided by 6 sigma. That means it is exactly the one. So if you see the lower and upper will cover entire range, and 6 sigma also cover the entire range, and therefore this is 1. This is 1 that indicates the process is just barely capable of staying within the specification of precisely centered. When this is greater than 1.33, this means managers typically require this. If you have this upper lower limit and upper limit and lower limit is higher, and then the CP index is higher than 1.33, then we can feel we have margin. So look into the few things here. Look into this. Interesting. Here you can see this situation. This is 1, means this is, you can see this is lower limit and this is upper limit. Upper limit and lower limit distance is exactly the distance of 6 sigma. So that distance, upper limit minus lower limit, I'm just, upon 6 sigma. That means this is actually divided by this part is, so which is 1, and therefore this we don't need, we don't want. The reason is that if anything goes little bit here and there, the process will be out of control. Why we don't need? If anything little bit here or there, the process will go out of control. The process will go anything out, means it will go after lower limit or after upper limit. So this is, manager don't want this, because otherwise their boss will bug on him. The process is not in your control. Therefore managers always look into this and beyond this. So look into this. This is 6 sigma range of the process. However, they have margin here, little bit margin, 1 sigma margin is here, extra margin. Means if little bit fluctuation in the process, that will not go upper limit, or it will not be called out of control, because you have margin here. You have margin here. Think about this situation. Here I have 2 sigma margin, here they have 2 sigma margin. That means this is 6 sigma. You have more margin, so manager have more margin in order to, and this is CP is 2. That means you have 3 sigma here, this is the 3 sigma here. That means how good, how sharp is the performance. The performance is not widely, the 6 sigma, think about here, 6 sigma is very wide. That means process has, you can see the distribution of process. This has larger 6 sigma, and here the 6 sigma range is smaller. That means the process is very, very, very consistent. Process is very consistent here. This 3 sigma and 3 sigma is leverage any manager can have, or any, if anything goes, some process goes like up to here, okay, that can be, but it doesn't go out of the limit. It doesn't go out of the limit. So this is process capability that we need to understand. So basically no one wants this, minimum this. And then the last thing is about CPK index, and this is basically minimum of both the limits, mu minus lower and upper. So this is divided by 3 sigma. Another process capability index which look at the same each. This is also safety margin. The word is safety margin. So this is another one which is minimum of both. And here you can see these are the another observations. Here, process is capable of meeting a specification if poorly centered. Look into these situations. Here you can see lower limit, upper limit process is meeting the specification that it should be within. Here also, but this is the best. Here, process is barely capable of meeting specification only if well centered. Only in this case, the central case, the process is able to meet the condition. In this case, it is going below, below lower limit, and here it is going above limit. Here, process is capable of meeting specification even, uh, you know, incapable of meeting even it is centered. So basically, what is the best thing? This. Just a minute. And how you can see, this is all about reading Six Sigma. What is the Six Sigma? Goal is 3.4 defects per million. And think about a very simple example. Just a minute. So in this, you have less mathematics, more of understanding. 3.4. So let's say UPS, how many package delivers UPS every day? Let's say I would say 1 million. This is the philosophy. If suppose Six Sigma, if so, out of 1 million, 999,000 996 or 97, I would say. These many packets UPS deliver on time on particular address. Only out of 1 million packages they can miss, or they can delay, or they can 3 packages or 3 or 4 parcels they will not be able to deliver on time, or they will deliver on different address, or wrong address. So this is the Six Sigma philosophy. Or who invented this? Motorola is the company, or organization which developed this uh, philosophy, or this. FedEx is doing, like, if you think about the Apple, they are also, most of the top fortune companies, they have Six Sigma quality control, Six Sigma policy. That means out of million, only 3 to 4 parcels or 3 to 4 defects can be tolerated. Think about if suppose UPS is only making one, let's say 100 package are not delivered on time, or 1,000 is less than 1%, less than 1%. So 1 million, so 10, yeah, 1,000 is less than 1%, 0.1%. So even if, so this is 1%, this is the one out of million. Even 1,000 parcels are not delivered on time, not on schedule, then there is a issue. So only this much, this is the goal of Six Sigma. Any production, if you see any organization is following Six Sigma, that means they are following this number out of million, up to 4 defects, up to 3 defects. This is the maximum cap they can tolerate. If they are having more than 3 or 4, that means that is not Six Sigma organization. So supply chain, I gave you the UPS, FedEx, these are the organizations following these. So this is what I wanted to. Here we have these options under stat control chart. So we have uh, so cause and effect here, this is capability analysis. Here we have, but we don't need to do, you need to just understand in case, because we don't have the data and we don't have the numerical on that. And if numerical is there in the book, that we have to do by manual thing. So I don't want you to go over there. There are 4 questions. Let me go through this. And you can always ask the questions. So basically it clearly gives X chart. Using given process parameters, plot a data on a control chart which automatically does it. Is this process is control? Explain your reason. So basically you can do very easily, very quickly. Now with mu and sigma, what is the meaning? Mu and sigma means this is given. Here you have known parameters. Remember that you have known parameters, and if you can see, sorry. So this is for if you have unknown mu and sigma, this is the case. If you have known, this is the how you can define the UCL and lower control limit. This is the thing. So you can also do this automatically. This is mu and sigma and LCN and L, these are given. You are just going to check rule 1 to 4. What you are going to check? Rule 1 to 4 that we have just, and again rule 1 to 4. So these are the 4 problems that I gave you for this assignment. If you have any question, you can ask me now.
Can I ask you a quick question on what I had sent an email to you. It was actually last homework.
Last homework, regression analysis?
Yes.
Yes.
I just had a quick question. Are we supposed to eyeball what regression model works best for those stocks, or is there a value that, or is there something that we're supposed to defend on? Because you said, you said you want us to do all of the different regression models on each of the 5 stocks that we did. So I'm just wondering, are we supposed to defend why we picked a certain regression model?
Yes. Yeah. Just you ask about forecasting, and the answer is here. So basically, that is just for your own understanding which model is going to be the best model out of 4, which has minimum, the accuracy measures parameters are minimum in which case. So basically,
Right.
which is going to be the best model for your best trend fit for your forecasting. So that is
meaning sorry to interrupt, but meaning what is going to value the stock the highest, or what is going to be the most accurate valuation?
Most accurate valuation.
Okay.
So
okay.
If you want, I can demonstrate you right here in just
Oh, no. I mean, I think you did it perfect with the Amazon one. I just wanted to make sure.
Yeah,
that we're supposed to pick one of the four that is most accurate to the actual trend line based on the
exact,
scatter plot, and
ex-
then say, okay, this is the stock we want to buy because of this model
exactly.
being the most. Okay, that's all. That's the only question I had.
Yeah, the most important thing, which is, but trend is going in the direction of the, in the historical data. That is the best one.
Right, right. Okay, I just wanted to make sure I was on the same page.
Yeah. And so
Thank you.
you just pick 5 stocks of your choice and do, and you can come to your decision. You are going to, out of these 5, XYZ or ABC, you are going to select C or
And
but
and do you want to see the forecasting model for the 5 stocks? Do you want to see each of the 4 forecasting models for those 5 stocks,
so
or just
basically
the one that we picked?
just the one you picked.
Okay. Okay. Thanks.
Most welcome. Any other question? If no, then I'm going to end the meeting. You can always ask me the question, and probably, I don't sleep till midnight, so even I will try to reply you, and some of you might be getting my replies even midnight. So just, let me know. So can I say bye bye?
Thank you.
Thank you.
Most welcome. Bye bye.